Welcome back to our series on electronics components. In the previous video, we explored resistors, one of the most essential elements in electronics. Today, we're diving into another crucial component, the capacitor. Whether you're an electronics enthusiast or just starting out, understanding capacitors is key to mastering circuits. So let's get started. What is a capacitor? A capacitor is an electronic component that stores and releases electrical energy. Think of it as a small, rechargeable battery that can charge and discharge very quickly. Capacitors are widely used in electronics for various purposes, including energy storage, signal filtering, and voltage regulation. They are fundamental to modern electronics, making them one of the most versatile components in a circuit.
Sir.
Symbol and units. In circuit diagrams, capacitors are represented by two parallel lines, either of equal length or with one curved line. The unit of capacitance is the farad, symbolized by the letter F. However, most capacitors are measured in microfarads, μF, nanofarads, NF, or picofarads, PF, because 1 farad is a very large value for typical electronic circuits. How does a capacitor work? Capacitors are made of two conductive plates separated by an insulating material called a dielectric. When connected to a power source, electrical energy charges the plates, creating an electric field. This stored energy can then be released when the capacitor is connected to a circuit. Unlike resistors, capacitors do not consume energy, they store it temporarily. Capacitors come in various types, each suited to specific applications. Some common types include 1. Electrolytic capacitors. Known for their high capacitance, they are used in power supply circuits. 2. Ceramic capacitors. These are small and commonly used for signal filtering and decoupling. 3. Film capacitors. These provide excellent stability and are used in audio and high-frequency circuits. 4. Supercapacitors. These have extremely high capacitance values and are used for energy storage applications. Each type has its unique properties and is chosen based on the circuit requirements. Applications of capacitors. Capacitors have a wide range of applications, including 1. Energy storage. They store energy for quick release in power supply circuits. 2. Filtering. Capacitors smooth out voltage fluctuation circuits, such as in power supplies. 3. Coupling and decoupling. They allow AC signals to pass while blocking DC and stabilize voltage in circuits. 4. Tuning circuits. Used in radios and TVs, they help select specific frequencies. Without capacitors, many electronic devices simply wouldn't function as they do today. Capacitor ratings and polarity. When working with capacitors, it's essential to consider their voltage rating, which indicates the maximum voltage they can handle. Exceeding this can damage the capacitor or cause it to fail. Some capacitors, like electrolytic ones, are polarized, meaning they must be connected in a specific direction. Always pay attention to the positive and negative terminals to avoid circuit issues. In our conclusion, that wraps up our introduction to capacitors. We've covered what they are, how they work, their types, and where they're used. Capacitors are an integral part of electronic circuits, and understanding them is crucial for anyone interested in electronics. If you found this video helpful, make sure to give it a thumbs up and subscribe to the channel for more exciting content on electronics. Drop a comment below on which component you'd like us to cover next. Until then, keep learning and exploring the world of electronics.